for the day, part 4, absolute values. So let's start with identifying what absolute values are. So absolute values will take a number and it'll tell you how much it is away from 0. So for example, if you had a number line, if you had 0 here and 5 was over here, the absolute value is how far away is that number from 0. So you would count the spaces. 1, 2, 3, 4, 5. So the absolute value is just 5. Now here's the other thing. If you put a negative 5 in here, it's the same distance. 1, 2, 3, 4, 5. So both numbers would have a distance of 5, so both numbers would have the same absolute value, 5. So in this case, that's what they're asking you. What number has an absolute value of 5? What numbers are 5 spaces away from 0? There's two answers, 5 and negative 5. Those are the two answers. So guys, absolute values have two answers most of the time because negative 5 and 5 both become positive 5s in it. Okay, so as we go on through this, what is the absolute value of a number that is 12? Well, A can either be a regular 12 and the absolute value of 12 is 12, or A can be negative 12 and the absolute value of negative 12 is 12. Okay, because if you take the absolute value, you wouldn't know which one it is. They both give you 12. So you put both of them as possible absolute values of 12. All right. Now, when it comes into an equation, though, you can't do that right away. You need the absolute values to be by themselves. So you got to move the 2 first using inverse operations. So we're going to subtract 2 from both sides. You're going to get the absolute value of n, and 5 minus 2 is 3. Now, this is where we're talking about the absolute value. What numbers have an absolute value of 3? Well, there's 2 of them, 3 and negative 3. And those are your answers, 3 and negative 3. Okay, now, you do have to be careful though. In this case, if you want the absolute value of y by itself, then we got to do something first, right? We got to move the 5 so that the absolute value of y can be by itself. Now, how do you move an adding 5? You subtract 5, inverse operations, right? Now, here's the problem. Minus 1 minus 5 doesn't become positive. We're not multiplying. We're adding together. So you get negative 6. Now, there is no number that has an absolute value of negative 6. Because when you're counting the spaces, you don't count negative. You always count in the positive. It's like if you were to measure how tall you are, you're always going to measure using positive numbers. You're never going to measure using negative numbers. So absolute values can never be negative. So in this case, guys, if you ever have the absolute value of a number is negative, that is no real solution. Or no solution. No solution is fine. Yeah, you can just write down no solution, and that's perfectly acceptable. Okay, next. Here we go. Let's talk about this one. Now, in this case, these are my absolute values right here. Okay, so the absolute value of this is 1. There's two possibilities. Either this equals 1. This expression inside is either a positive 1 or the expression inside is a negative 1. There's two possibilities. So you solve for both possibilities. In this case, we're going to subtract 3, and actually in both cases we subtract 3. And whatever you do to one side, you do to the other. So this is why sometimes you end up with two different answers. Here, you can have a negative 2, but here you can have a negative 4. And here's why. If you plug in a negative 2 plus 3 is 1, and the absolute value of 1 is 1. But if you plug in a negative 4 plus 3 is negative 1. And the absolute value of negative 1 is going to be 1. So, two answers. Okay? Next. sorry, this one first. Here, before we deal with the absolute values, which are these parts right here, you got to get rid of this 3. Now this 3 is multiplying the absolute value, so we're going to divide to get rid of it. That's the inverse operation. So you're going to get the absolute value of 2w is -2. And again, we come up with this issue. The absolute values should never give you a negative answer. So this is a no solution. And we move on to this one. All right. Now, before we deal with the 5, you got to deal with the number on the outside, which is a 4. That is multiplying. So we're going to get rid of that 4. We do not distribute here. Do not distribute these. Okay, you have to cancel them out. So we divide. So you get this. Now again, that means whatever's in here is either going to give you a +4 or a -4, because that's the only way to get an absolute value of 4. This inside, either whatever's inside of this is a 4 or it's a -4. And you got to solve for both possibilities. For this one, you subtract 5. You're going to get -1 as a possibility. Here you subtract 5. So it's the same step, but a different answer. What that means is, if you plug in a -1 in here, -1 plus 5 will be a 4. And the absolute value of 4 is 4. But if you plug in a -9, -9 plus 5 is -4. And if you put a -4 inside absolute values, you still get 4. So these are your two answers here. Okay. Now, let's talk about inequalities for a second. Inequalities, okay? The way inequalities work is very similar with an exception, okay? When you have absolute values, again, you're going to set up two possibilities. Either this inside is less than or equal to 10, or it is a -10 that you work with. Now here's going to be the difference. If you change the sign of the 10, you have to change this sign. So you flip it. So you have one that stays the same, but with a negative you flip it. And you have to solve for both. So in this case, I subtract 3. I get x is less than 7. In this case, when I subtract 3, it won't be 7, because -10 minus 3 is -13. So you have two different answers. You have two distinct answers, and you can graph them on a compound as a compound inequality. So let's just say 7's over here, and actually -13 should be over here, -13, and then 7's over here, right? So x is less than 7, so it'll be an open circle going this way. X is greater than 13, so it'll be an open circle going this way. So your graph for this, if you put both answers on a graph, will look like this. They combine. This one was going less than, x is less than, this one's greater than, so it goes greater than, like that. And that's what the answer would look like as a graph, a compound inequality. Okay, last one here. Same deal. You have to solve for it for two circumstances. Either it's a +4 or it's a -4, in which case you flip the inequality. You flip it like that. Okay, and then we have to solve for both of them. So here, we're going to solve for both of these. We're going to move the 1/2 by doing subtracting 1/2, which you could probably do it to both sides. Subtract 1/2. Okay, you get 2t is less than or equal to 3.5, or you get 2t is greater than or equal to -4.5. Okay. Next, we're going to divide by 2. So in this case, you're going to get, let's see, if you divide that by a half, you should probably use a calculator for this. I get 1 3/4. Here, if I divide this, I get -2 1/4. So those are my answers. Now, if I was going to put these on the number line, these kinds of numbers, right? Let's think about this. -2 1/4 would be somewhere over here, and it'd be a closed circle. And that says greater than, so it goes this way. This one, 1 3/4 would be somewhere over here, also a closed circle. T is less than, it goes this way. So they're not going in opposite directions, they're going in the same direction. So it looks just like the other one. These are where your answers are for T, from here to here. Those are your answers. And guys, that's basically how we solved an absolute value. It looks a lot like compound inequalities. You take that problem, you turn it into two different answers, one positive, one negative, and you solve them both. And that's how you do it.